So that's me. My name is Peter Jakobsson, and I've been commercially developing in 4D for about 25 years, or I can't really remember when I started now. Mainly for a wide variety of companies, but largely doing financial orientated systems. So not necessarily directly financial systems, but most of them with some kind of mission critical transactional nature. Bike stores, oil companies, plumbing companies, all wanting to do similar things, but in very different ways. During the first half of this talk, I'm going to present a few of the concepts to do with atomic programming that over the years I've discovered are very useful, because you can start off using 4D transactions. I mean, how many of us are familiar with using 4D transactions and use them comfortably? Right, so sort of at least half. So it's something that most 4D developers use. Some don't. When I started developing, I didn't use them at all because I thought, oh, I'm not going to use that. It's too difficult. It looks like I can do a lot of damage. But then I started to have customers with problems because they had SCSI drives connected that then disconnected and databases crashed. And the database was okay, but the data wasn't okay. So debits didn't equal credits and things didn't add up. So the concepts in this presentation are more about the strategy behind atomic programming. So let's just imagine for a moment, just imagination, no pictures for this one, that the save record command, everybody knows save record, didn't work the way that we normally expect it to work. It didn't work the way that we're used to. So instead of just calling save record and it either does something useful or nothing at all, it works something like this. So you execute the command, goes away, comes back and says, okay, 3 fields, no problem. Managed to save them fine. You know. 2 of them, some tussle with the operating system. I'm not too sure about them. One of them, there was a constraint violation. Yeah? Closer. Sorry, microphone. One of them was a constraint violation. I just left that one alone. But 3 fields is pretty good. We wouldn't think that was very good, would we? We probably wouldn't buy 4D, because the reason that most people buy 4D and use it is because it includes a lot of high-level atomic commands. So in its command set, it lets us do stuff that we would have to write a lot of code for and interact with the operating system. And 4D developers don't usually want to do that, so we like to use atomic code. And save record is a good example of an atomic piece of code that belongs to 4D. But then the question arises, we've got a whole lot of code of our own, full of business logic, that the 4D programming team don't know anything about. And what happens with our code? What happens? 4D cannot know where our code should be atomic, or what parts of our database need to exist for another part to be valid. For example, if you have a web sales order, when your customer clicks OK on your sales order, usually your 4D database saves records across, maybe 3, 4, 5, 6 different tables. And if that operation is not atomic, then your customer, our customer's customer, so the people that are buying the products, they may end up with only 2 products when they ordered 4, or they maybe have their credit card details lost or whatever. So that's not satisfactory. So we need to continue this pattern into our own code and make it atomic as well. So we're going to look at some of the programming concepts behind and the strategy behind building atomic code. So there's 4D's code and our code. Just a quick point about architecture, because this is really the third in a series of talks that I've given on architectural concepts. So structuring our code in a way that makes sense and is easy to evolve, so it doesn't get more and more and more and more complex as it gets bigger. And I've looked for ways to delineate code that are natural, as opposed to creating walls in the code. You start off when you're developing in 4D, I'll just make this a contact module, prefix everything CTC, or I'll just make this a stock module, prefix everything STK. And then you think, oh, that bit really needs to talk to that bit. And sometimes these work and sometimes don't. But there are ways in which we can structure our code naturally according to natural delineations in 4D. And the first talk I gave about this was 2 years ago. I used the idea of stateful and stateless method groups. So sometimes you have a group of methods that operate on a record, for example, accessor methods and so on. And then sometimes you have a method that just executes a query and forgets about it. That's stateless. Then I used the idea of business modules, the classic one. Then 4D components, which is one that 4D give us as a present. We don't need to think about it because it's separate structures. And this talk is about atomic code units. So this is a different perspective on atomic programming, an architectural perspective. Doesn't mean we have to rename all our methods. It's just another way of thinking, another useful perspective. So if we look at these all together, we had stateful, stateless, the business packs vertical, so we might have a stock module there, a contact management module there, and so on. Then we have got our 4D components. And the interesting thing about atomic code units from an architectural point of view is that they cover all of these. So in one atomic code unit, you could have both stateful and stateless code. You can have code from different business modules that you have, and you can have component code and host code, as you'll see there's an example of that in the sources on your key disks. Right, that's an oil rig. This is just an interesting kind of anecdote that I thought I would drop in because when we're working with customers, whether it's you work for a company or you're a contractor, sometimes they tell us interesting things. One customer that I worked with pointed something out to me when we were having a discussion about management. I think in the UK they were reorganizing the health service or something like that. And I said, oh, there's too many managers. We need to get rid of all these managers, more production staff. And he said, no, you can never have enough managers. You need more managers. And he pointed out to me that in the oil industry, on an oil rig where the action is, you have a few thousand employees, and then in the offices, you've got hundreds of thousand employees. So I went and checked this out, and sure enough, it turns out in the UK oil and gas industry, 28,000 people work here, and 142,000 pen pushers tell them where to put the rig to get some oil out. So I thought this was appropriate because we're going to look at the business end of atomic code is really only 3 commands. 4D gives us these commands out of the box, and it's so easy to create a transaction in 4D. You just say start transaction, do some stuff, check for an error, validate it, or cancel it. But in actual fact, to really lever when you think through what's on offer there, the ability to split the database into 2 worlds like Schrodinger's cat, where you don't know if the cat's dead or alive until you open the box, there are quite a lot of possibilities. So the real work goes on where the action isn't, just like the oil rig. It's on this side, and I'm going to look at some of the concepts involved there. This is the industry perspective on transactions. How many have heard of the ACID paradigm, or familiar with the ACID paradigm? Right, so sort of minority there. So more people you see, a lot of you use transactions, but hardly ever anybody's heard of the ACID paradigm. And that was one of the reasons I wanted to do this talk, because I thought maybe some of these concepts are underappreciated. And I didn't. I'm the same. I didn't know much about it. because 4D, you don't know stuff. It's so easy to do things out of the box. The ACID paradigm is, what is it? I actually need to read it off my notes here. It describes a set of properties that a database has to have to guarantee validity in the event of errors. So, I mean, that sounds quite cool, really, because, your database can never fail. It sounds like it can all... If you go to Wikipedia and you read about this, it really looks fantastic. And it turns out that 4D supports this very well. And when you read it, if you've never come across the ACID paradigm, suddenly a lot of things that 4D's done in the last 15 years make a lot of sense. You see, oh, that's why they did. Oh, okay. It all fits into this structure. So what is it, and how does 4D support it? It's basically, as I say, a set of... It's a loose standard that allows for recoverability in the event of a crash. And it means that your database must always be recoverable, even if the power goes off and even if it crashes at the worst possible moment. The A stands for atomicity. I won't talk too much about that because the rest of the presentation is on it. C is consistency. And what's meant there is the consistency of your business data. And 4D supports consistency in two ways. One is it lets us give attributes to our fields in the structure. So we can make fields mandatory, unique, whatever you like. And if a user saves data that's not consistent with that structural definition that we've given it, 4D will throw an error. The second way is obviously through code. So we can write oodles of code to implement very sophisticated constraints. I is for isolation, and what that means is that any operation that you carry out with 100 users connected to the database should have exactly the same result as it would have if you had done it in single user mode. And to support that, 4D gives us record locking, so we are able to know that we have unique access to a particular record. So it's kind of like weaving the users, in amongst each other. That's isolation. You do something in a multi-user database and you're isolated from everybody else. Durability simply means that anything you do in the database sticks. So if we complete a transaction and we validate the transaction or just save a record, that should stick even though there is no, the data's still in the cache. And 4D supports that using the log file, obviously. So 4D didn't always support the ACID paradigm fully, but over the years, I've used this approach increasingly and found that it supports it superbly if you implement your own logic. You continue where 4D left off and you implement atomic code just using a few simple rules in your own logic. It can become incredibly reliable. Right. So starting to get down to the nitty-gritty. So this is how do we write a piece of atomic code in 4D? There are three core elements that I call them the Holy Trinity, just because they're whenever I develop a piece of atomic code, I'm doing the same thing again and again with the same three things. Transaction control is those three 4D commands: start transaction, validate, and cancel. That's the easy bit. Trigger logic is I've put trigger logic up there because triggers and transactions go hand in glove. One is very useful to the other. We don't need to use triggers to write atomic code. They're not a requisite part of the atomic paradigm. It's just that they're so very useful when we are writing code because for two reasons. One is that we can push much of our business logic out of our forms and onto the server, which later on I'll describe as a kind of middle tier really between the client and the database engine. And the second reason is that it helps to make our code stateless. And statelessness is essential for two main situations. One is unattended servers like mobiles and web servers, and the other is unattended API clients. Basically anything unattended where you haven't got a user answering questions when there's a problem. So triggers, transactions, they go hand in glove. And finally, error handling. Everything we do inside a transaction has to be error handled, because if not, you can leave the transaction hanging, 4D takes over, user gets a message, and you really don't know what's going to happen then. You've got this dual state. You don't really know. Your code can't know if the transaction's going to be closed, so we need to pay attention to that. Here's something that I'm going to spend a wee bit of time on, because this is quite interesting, and it's something that we tend not to notice. We kind of drift into it. Who's heard of pessimistic and optimistic record locking? Right, so most people, and I heard Thomas mention it earlier on this morning, but he didn't explain it, and I thought, oh, that means everybody must know what this means. I'm wasting my time. But in actual fact, it goes further, because, well, let's look at it first. 4D uses pessimistic logic flows in its basic form. Out of the box, it uses pessimistic record locking, and in general, that means we check things first before we do anything. It's like, let's say that table's a record, you know, and I'm the that execution point in the debugger where you click, 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 and I'm the execution point, and I can see the record coming up, and I'm going through the code, and I see this record's coming up, and oh no, I'm starting to get nervous. It might be, you know, another user might be using that record, and I'm going to have to make a modification here. I better check, you know, that I've got this record to myself. That's how pessimistic record locking works. And 4D gives us the locked command to check the record, you know, first before we do anything. So I can kind of get inside the record, cross this locked barrier, and I'm relieved. You know, relieved. I know I've got the record all to myself. So that is really just a kind of specific case of a more general way of working in 4D, where we check things preemptively before we do them, and then we commit to a change. You know, so save record. Have I got all the data there? Yes, okay, right, execute, save record. So optimistic is completely upside down. It just works completely the other way around. Here, we don't bother checking anything before we make a change. We just go right on and do it and worry about it later. You know, almost everything, record locking, constraints, you know, you name it. We don't bother checking them. We just go in and we wait for an error to emerge. And if one emerges, then we say, oh, something went wrong somewhere. We don't care what it is. And we just cancel transaction, and all the changes evaporate in a cloud, and they go away. And we don't have anything to worry about. So there are quite a few advantages of working this way. Not least, once again, it helps if you're needing to write stateless code. Of course, there's never one better than the other. This is also a very the pessimistic approach is also a very useful way of working. It gives us lots of benefits. But when we're using transactions, the optimistic logic flow is more the natural way to work. So we commit to the update first. Then we check if something's locked. We do some data validations. We can go all over the place, and if we get just one error anywhere, the whole lot will unravel, which is very useful. We decide to bin it or keep it. Right, this is going back to the idea of the Holy Trinity again with the triggers, and I mentioned earlier that we don't need to use triggers when we're developing atomic code. We can write it without them. But I wanted just to touch on this subject of three-tiered architectures, because it can be useful to think of your code in this way when you're writing it, even if you don't literally implement it on a middle tier. When we're using triggers, I tend to think of the layer of the 4D server that allows you to execute code as a middle tier. And in fact, in the 90s, Microsoft came out with a product, better wash my mouth out there, called Transaction Server, which basically what that was a facility to allow databases to scale. And what they did was have a middle tier of real PCs where you could execute code, and that code could talk to both the clients and the server, and all the kind of clever stuff went on in the middle. And 4D does actually support this way of working very well. It's maybe not on a literal tier. We can configure it as 3-tier, but if we think of our transactions as containing the business logic, then we can write, once again, stateless code, where on the client, we just simply do very little. We populate a field, we call save record, and everything goes on in this middle business logic tier. This is a real 3-tier configuration for 4D, an example, because we can run it in 3-tier, and increasing numbers are now. We can, for example, have mobile clients talking to 4D remote and 4D remote talking to the data server. Okay, I'm going to hurry up a wee bit because I think, how are we for time? Error handling. Right, this is the third one in the Holy Trinity. How much have I got till 5:30? Left until 5:30. Oh, fantastic. Right. Okay, what is error handling? Because this is a kind of huge area, huge nebulous subject, and people implement it in lots of different ways. And I find it's another thing that I find quite interesting, because 4D gives us this command on error call, where you can just shove one of your methods into that command as an argument, and suddenly you've got error handling everywhere. But if we think about it a little bit more carefully, error handling is really two things. First of all, it's error suppression, because 4D already does error handling out of the box. You know, even if we don't implement our own, if we try and save a record that has that violates a constraint, you know, a non-unique field that's supposed to be unique or something like that, it will throw an error, and the user will get a nice message. Maybe not so nice, it depends on your users. Right? So it does do error handling. When we do our own error handling, we need to do two things. One is suppress, and the other one is respond. Because by calling on error call, all we're doing is suppressing 4D's error handling and implementing our own. But we've not done the response bit yet. And that's a problem, because if you only do the suppression, then your error handler doesn't know what your code was supposed to be doing when it invoked the error. And that means your database will be left in an ambiguous state. And as we know, computers don't like ambiguity. So in the notes and in the code, I've suggested this approach where we wrap our commands that we need to error handle with a specific error handling call, and we only do error handling for that command, and then we respond to it immediately after. And in the demo, all that error handler does is just cache the error. It just caches the 4D's error variable, and then we can call a function to our own code here to retrieve what the error was, and then the code can continue to execute, knowing what to do, because this method knows what it was meant to be doing when the error occurred. Now, you'll see, remember at the start I pointed out those two little green functions from the toolbox, and one of them was a wrapper for save record. So this is in the toolbox, in the component. That's what that wrapper looks like. So we don't even need to implement error handling in the host. We just call that function, and it will return an error or save the record. So error handling is the main concept there is these two things, suppression and response. Finally, this is something that is specific, again, to atomic coding, because when you're writing code for transactions, it's kind of different from writing normal code, not because the code's different, the priorities are different. Suddenly, you have to think about error handling, you have to think about making everything into a function instead of a method, because the error needs to get back through the call chain, and so on. So certain things can be disruptive to your flow, and one of them is thinking up error numbers that are compatible with 4D's global error numbering system. So in the toolbox, you'll find a way to make local error numbers for your modules. So you can just call your error 1, 2, 3, 4 and not think about 4D's error numbering, and then use this local to global function to map it to one of these compatible 4D compatible errors. Now the nice thing about this, that 4D lets us do this, is that the whole database engine, we can invent an error, our own error that's very specific to our business logic, and the database engine will support it. It doesn't matter if it's a web application, a native application. It's a very powerful feature of 4D, and it also works really well, as everything in 4D does, of course. Right, this is just a quick fun thing about psychology, because you tend to find, when we're coding, we start, I'll just use a transaction here, so start transaction, and then we write it. But I tended to find, you get into the code and you think, God, I've spent 4 hours of this already, and I've only done X, Y, Z, what's going on? And it's because you're having to do, remember the oil rig in the office? You're having to go and spend so much time in the office before you can go back to the oil rig and start drilling again. You have to do error handling, you have to think about structuring your code more, because some might be in a trigger and some's running something else. So it's a good psychological exercise to do like those 4-wheel drive Jeeps, how you have to stop them, put them into some 4-wheel drive mode and then start the engine again and get moving. So that's a psychological consideration. We have start mental transaction and validate mental transaction. And we need to revise our expectations, our productivity expectations, because it can take longer, but it's worth it. We get incredibly robust code. Right, is that past? Oh, I'm on time. I'll maybe take a couple of quick questions if you have any. Has anybody got any so far? You're all quite happy.
It was very clear.
Is there a what?
It was very clear.
It was very clear. All right. Well, that gives me more time to do the risky bit then with the demo. By the way, when I was talking about the error handling, when a lot of people put an error handler in the startup and then just leave it, and they do that sometimes because they don't want to give the users a heart attack. The user doesn't like seeing these messages, and also it's bad for the company. They might sue that something went wrong. But it might go wrong. Maybe the database gets a heart attack. So it's not always users are very difficult to predict anyway. Usually we think we're doing something that they'll love, and they just don't like it. They want something completely different. And a quick anecdote about that. I was once working for a plumbing company, way back, a small plumbing company. And the thing about this company was that they had the word emergency in the title, because they were the type of company that you call when you got water coming through the ceiling and all over your house. You have to phone and get someone in 10 minutes, not 10 days. But the problem they had was their customers thought that this was a free service. They thought it was like an ambulance or the fire brigade or something, So once they got everything fixed, they didn't want to pay. They thought the government was going to pay. So I had to write this system to pump out letters and invoices saying, you got to pay, you know, we did this work. And this was 1991 or 2, you know, Mac Plus, SE. You couldn't just go for a coffee while it was printing. You could go to the next town and have a 3-course meal and a bottle of wine, you know. So I wrote this progress thermometer to sort of show. I used display record, a very old command in 4D. It just looped. And I showed it to the boss one day. I was very pleased with it. I said, "What's that?" I said, "Progress thermometer." He says, "Why do you need to know the temperature?" I said, No, it shows you, you know, I explained what that was. It shows you the computer's doing something, blah, blah, blah. And he says, "Oh." And then he came back the next day and he said, "Look, see that thermometer thing, you know, just get rid of that. I don't want that. Just put a message saying, the computer is working, are you?" And, you know, I didn't know how to respond to that. I think I refused to implement it on ethical grounds, you know, and then he laughed at that ever since. Okay, so that's users. We can't predict them. So designing the atomic tier, right? This is a little case study where I use the technique of a brokering record. Also going to look at some other. I probably won't get to all of these, but they're fairly simple to you know. There's some explanations in the notes, but I'm going to look at this brokering approach first. This is where this is back to this 3-tier example where we can suck out a lot of the business logic from our forms and run it on 4D's pseudo middle tier, which is the server, or a real middle tier if you've got a 3-tier configuration like I showed before. And what we're going to do here is do something very complex, but make it look very simple on the client by just calling save record and do all the work in triggers inside what I call the atomic tier. So we have here, this is a double entry bookkeeping system from classic accounting. So double entry accounting, we have a set of accounts. We need to debit some, credit some, and we need to make sure that debits equal credits. So this is a classic situation where we cannot have the operation stop or fail in the middle. It either has to all work or all not work, because if there's one thing that gets accountants' blood pressure and gets them bouncing off the walls, it's if debits don't equal credits. So we need to use atomic programming here. This is a journal header. So these two tables here are a classic header and row table, like an invoice. So we've got an invoice header, and then we have the rows. These are the rows, and these are the accounts. And each one of these records, each one of the records in this table has a balance. And when we save one row from the journal, it should access the account balance, update it or downdate it, and save it again. So that's all it does. So we've got a cascade here of 3 things: the journal header, the postings row, and the account balances. The journal header has a field in it that is an object field, which is stuffed with the row data. So when we save it, we're not even having to save the postings. We just save the header, and it's going to loop through the rows inside this object. It's going to do get object until there's no rows left. And the trigger in the journal record, so this is all happening inside the save record command for journals, no other tables being accessed on the client. The trigger will save one postings record for each of the rows in the object field of the journal header. So is that clear enough how that's working? Okay, so here's a typical algorithm. I've just, you know, there's hundreds of algorithms. There are lots of 4D developers doing this. This is nothing new. But I thought this is quite a good algorithm to illustrate the type of approach and how different it is from the sequential approach. So here we have some schematics of our journal header. And this is just a field in the journal header with an amount that the user has entered. The user thinks that it has 90 euros worth of debits to post. These little circles here are the postings records that have yet to be made. That's that middle table. And these are the master account records. So the way this works is our header trigger loops through each row in the object. It saves the postings record. That will run the trigger in the postings record, which has its own little world. It only has one job to do, which is to load the associated account balance, update it or downdate it, and save the associated account balance. And as it's doing that, it's calling save record, obviously, for the account balance file. That will run the trigger in the account balance table, which will, again, it has its own little world that only it has to worry about. So it will pass the error back to the postings file if any constraints were violated. And the postings table can then pass the error back to the journal header and say, look, I don't know what you were trying to do there, but it didn't work. Just forget it. And the journal header will then pass the error back to the client. And our client code is, of course, very simple because it's just save record. So we only need to error handle save record. Oh, we got an error. We don't know where it came from, somewhere deep down in this chain. Cancel transaction. And we've unraveled all this complexity in a oneer. Now, the other thing is that we can go from the microscopic to the macroscopic here. And this is another beauty of this type of atomic coding approach, because each of these little lines are checking its own, are imposing its own constraints. And when we get to the end, when the header gets to the end, it itself is going to check that it's got 0 left. So it's downdating the control amount in the header every time it saves one of these postings records. So I saved 20, I didn't get an error, reduced by 20, and so on. And even if none of these generated any error, if that has a non-zero balance in it at the end of all this process, the header itself will generate a kind of master error and saying, well, everything seemed to go okay, but it hasn't gone okay, so tell the user they've got something wrong, debits didn't equal credits. So our atomic code unit will not allow that data to pass into the database. And in that way, we've protected the logical integrity, not just at 4D's level, but of our database applications level, but using 4D's engine as a vehicle to do so. Because somebody's running save record on the client, and they're just testing for an error coming back from save record. They're just doing normal 4D stuff. And all this logic is running inside that command. So that is one of the ways. Now, if we imagine for a minute the over here, this is the account balances record. Let's say we want to add a constraint in there. We just want to drop it in like a helicopter. We don't want the balance to go negative, for example. We don't want any account. You wouldn't do that, but let's say you want some constraint out of the blue. Another one of the advantages of atomic programming is we can do that without, and we can even do it in code. We can add code into the trigger constraints on the account balance record. We can do that without revising the overall logic of our main atomic code unit. We can just helicopter in out of nowhere into one of these records. We can add rules and so on without making more complex without making this algorithm more complex. And that's extremely powerful, and it means your databases can get more and more complex when your users ask for more rules. You can stay in control. And that is known as aspect-oriented programming. Is where we can do that. We can just sort of drop rules in. Sometimes people write log files. They use it to put a log file. I suddenly want to log all these operations. You can look that up in Wikipedia. It's quite interesting. It supports aspect-oriented programming. Okay, these are a few points to finish up with. How much time we got left? 5:41. All right, 20 minutes left. That's every time I thought I was going to have. I'll have to tell more jokes. I haven't got any. Right. Okay, that means I can spend a wee bit of time on these. Well, first, I'll maybe just show you a demo. That's what I'll do. I'll get a seat for a minute. So, this is this is the demo that you've got. And, okay, my screen is all gone weird, but if you open up the demo in the sources, it's called mini accounting something, but it's easy to find. There's a menu here called testing, and one of the things that I didn't mention too significantly was in this approach. Another advantage of it is that it lets you do unit testing. Very, very powerful unit testing, because you can drop yourself into one of these levels in the trigger flow. For example, you can sit on the posting record and just test that part of the logic. So there's an example of this here. First of all, I'm going to just show you it working. My screen resolution's too small. I don't suppose I can I do anything about that? Let's see if I can get it back to where it was. Okay, I can. That's great. Maybe that's a bit. Maybe we want that one. Okay, we can see that. Right, in this testing menu, you can try this out for yourselves. First of all, there's an example of the optimistic locking. Now, can you see that code there where we've just got, we're making a modification. I've just assigned a field to itself, and then I've used the save from the toolbox to save the record and return an error. So there's no if locked being tested there. It's just going straight in and making the modification and then calling that code to save the record. And if I lock one of the records, then I'll get a database engine message saying that it's locked. Similarly, if I go to the header record, so I'm now going to do modify record, the command modify record, on this journal table here. And I'm going to unit test it. So I'm loading a sales journal. I'm just going to hide these guides here. And up here, this list box is showing the content of the object field that contains the postings rows. And with this menu, I can execute that algorithm that I just demonstrated in the keynote slide. So I'm going to post it, and down here you should see the balance totals changing. This trial balance display is loading all the balances from that third file, the one over at the right, with all the balances, so I can see in real time. So I've just included this in the input form for the journals table. So I can post and unpost all day long here, and we can see our postings having effect. It's updating these balances. And over here, if you click this button here, I'm now going to lock one of the records, just as an example of a constraint violation. And then I'm going to go back here. So that record is now locked in another process. I'm going to post, and it couldn't be completed. Now, this is an error that's specific to my own errors. So this is one of our developer-level errors that 4D supports right through the database engine, and you can see how transparently we can use that. So the unit testing aspect of this type of coding is a very powerful feature. So I'll go back and finish off with some of these points here. This is just demonstrating that we can have canonical business logic and custom data, because 4D objects kind of is a turbo boost feature for atomic programming, because we can implement our core logic, as I've done here, and then we can continue to grow custom data in this one field. We can just pack this field more with more stuff and send it to the trigger. we need to error test any object code. So when that trigger is unpacking the object field, that's a kind of a dangerous thing to do because we know that objects can generate errors. So you need to check for that the property exists, and need to check for type mismatch errors at least. And in the toolbox, there are tools for doing that. This is one here. You can't actually see the code there, but what we're doing there is just pulling a property out of the object field and returning an error if it does all the checking for the object and returning it all the way up the call chain. Canonical maintenance actions are an extension of that middle tier logic. So what happens here is, over on the left we have a field that says utility ID, and that's normally 0, or it's -1 for none in the sources. If we put a maintenance action in there, like we make that field equal to 1 or 2 or 3, the trigger will test that field, and instead of running the regular trigger, we'll run the maintenance action. So that gives you a way to support your users, or because you might know there's something that regularly needs done. For example, you need to clear out a history field, or reset the balances or whatever. Canonical maintenance actions are an extension of that, and there's an example. There's 2 or 3 examples again in the source code for you to have a look at. This is a handy way of switching off all the error handling and switching off all the triggers. You've got to remember that error handling is in a kind of matrix. Those noughts and crosses squares, those games of noughts and crosses. Well, imagine the vertical lines are processes and the horizontal lines are components. So when you use on error call, it works inside one of those squares. That's the scope of that command. And this is a little tool in the toolbox that can switch off the triggers using a global variable. Right, this is quite an important one, very important in fact. When we're designing conceptual diagrams for customers, working with them and then turning them into tables, we sometimes get this. Okay, the customer record has got a name, address, and a balance. But then what happens, the problem with that is that a customer might be sitting on a user may be accessing a customer record. And one thing users are not too great at is, when they're needing to go to the toilet or for a coffee break, or their friend comes and drags them away for a hydraulic lunch, they're not so great at saying, hang on a minute, there's this bit of atomic code coming along tonight at 6:30 that's going to need this record. I better just cancel out of it, and I better do a search just so it's not the current record anymore, so the balance is available. So it's going to upset all of our atomic code, beautiful atomic code, if we weld the balance into the customer record. We need to extract the operational fields, from the, any code that triggers need to regularly access need to be taken out of the master table and given their own table. And that way, you'll never have any record locking problems. That can run all day long, and even if somebody goes and sits on the customer record, it won't have a problem. You'll still be able to update the balance. And this is quite easy to implement because you can have a trigger in the customer record that just creates the balance table and keeps it up to date whenever a customer record is created. So it's very little work to implement that. This is especially important for web servers or any unattended use, because obviously there isn't somebody sitting there saying, a record is in use by another user, can you do something about it? Okay, so there it is in real life. I've separated the account master from the balances table. I didn't show you that bit before, this table over to the right. This is simply a little point on modularity. If you write code with start transaction in it, that method may get called by another method that is also inside a transaction. So we don't know at the time that we develop the code whether that how many layers down. So we can either just not think about it because 4D now supports nested transactions, which is fantastic, or you can write your method with an isolation parameter that tells the method, it's okay, somebody upstairs already started a transaction, don't bother, you don't need to launch your transaction. Or you can make it more isolated where it runs its transaction. But then you need to bear in mind how the error handling is going to work. Because if a sub-transaction fails, the question is, do you want to keep everything else inside the main transaction, or do you want to bin it as well? So you need to think about the error chain. That's really only the developer can decide that, because that's our requirements question. So we can nest the transaction. Here's what the mode looks like. There's some custom constants in the session sources for this. That's them there. Run as isolated or run as continuous, I think the other one is. I call this a get out of jail free card. This is 4D's new suspend transaction command, which is kind of like a godsend for a lot of people because they can stop the transaction, go and do something that they definitely want to keep, like update a parameter record that creates a new invoice number, and then go back into the transaction. But I would recommend that only use that as a kind of backup if you get into trouble. It's not such a great idea necessarily. It might be. You can never say anything's always right or always wrong, because there's always somebody that does it and has got all the bases covered. In general, the warning is that it's no longer atomic, because instead of all or nothing, you've got all or something now if you use suspend transaction. So that just has to be kept in mind. Finally, numbered sequences, allocating invoice numbers inside transactions. Sequence number doesn't work because 4D will use another number. You need to use, for example, a parameter record where you increment it. And the best one is a parameter record where if the transaction gets cancelled, you throw the invoice number back on the stack and it gets used again. But that's a bit beyond the scope of the talk. Okay, so I won't go through these because these are just a list. This is just a little checklist for you that you can read when you're on the train or plane. Tips and a little checklist of things that you might want to bear in mind when you're embarking on writing this kind of code. Okay, so that's us. If you want to ask me any questions, you can either do so now or over a glass of wine this evening or any time during the rest of the summit. I hope you found something useful there. And I'll remind them about the feedback. Yeah, so the feedback, feel free to give your feedback. As I say, if there are things that you thought should have been covered and weren't, or were covered and I hadn't done my homework, or you liked what you saw, whatever, right? Just, I think with the number of people that are at this summit, I was saying to some people earlier that I used to go to the summits in the early 90s, and this is the most well-attended summit that I've seen, I think, since 94 or something like that. So it's 4D are doing something that seems to be popular. So thank you very much. As I say,